Example, find dy dx and the slope of the graph of the polar curve at the given value of theta. R is equal to 2 plus 2 sine theta. Theta is equal to pi over 2. We want to find the slope of the graph at pi over 2. And we need to find out what y over x is so that we can take the derivative. Well, y is equal to r sine of theta, and x is equal to r cosine of theta. But that's equal to, now r is 2 plus 2 sine theta, so we have 2 plus 2 sine theta times sine theta over 2 plus 2 sine theta times cosine theta. And now in order to find the slope of the curve, we have to take the derivative of dy over dx. That's equal to first times derivative of second plus second times the derivative of the first, which is 2 cosine of theta, all over first times derivative of second, which is negative sine of theta, plus second times the derivative of the first, which is 2 cosine theta. There's the derivative, and now we have to evaluate this. We'll evaluate it at theta equals pi over 2. And that's equal to 2 plus, let's see, the sine of pi over 2 is 1, so that'll be 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, and then 2 times 0. All over 2 plus 2 sine of pi over 2 is 1. So 2 plus 2, and then negative sine of theta is negative 1, plus cosine of pi over 2 is 0, and then 2 times 0, which is equal to, we'll have 0 there, and we'll have 0 here. 0 over, this is going to be negative 4, and that is 0. So it turns out to be 0. So apparently at pi over 2, the slope of the tangent line is 0. Well, let's see if that's true. We have 0, pi over 2, pi, and then we have 3 pi over 2, and 2 pi. And then if we plug those values into the original equation, we get sine of 0 is 0, so we get 2. Sine of pi over 2 is 1, that's 4. Sine of pi is 0, that's 2. 3 pi over 2, that's negative 1. So we have 0, and then we're back to 2. So let's graph this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So at 0, we're at 2. At pi over 2, we're at 4. At pi, we're at 2. At 3 pi over 2, 0. And at 2 pi, we're back to 0. So the graph looks something like that. And what we found out is the slope of the tangent line at pi over 2 should be 0. And in fact, it is right there. Find the points of horizontal and vertical tangency to the graph of, well, this graph. We need y over x, which is equal to r times sine over r, 2 minus 2 cosine of theta, times cosine of theta. So there's r sine over r cosine, which is really y over x. Well, we have to take the derivative. So we have dy over dx is equal to first times the derivative of the second plus the second, and then times the derivative of the first, which is going to be 2 sine theta. And then all over first times the derivative of the second plus the second times the derivative of the first, which will be 2 sine theta. And now let's do a little simplifying. We have 2 cosine of theta minus 2 cosine squared theta plus 2 sine squared theta. And then all over, when we do the distributive property, we get negative 2 sine theta plus 2 sine theta cosine theta, and then plus 2 sine theta cosine theta. That's equal to 2 cosine of theta minus 2 times cosine squared theta minus sine squared theta. And then all over, we have negative 2 sine theta plus, I'm going to write this a little strange, we have 2 times 2 sine theta cosine theta, which is really 4 theta. We have 2 twice. Well, that's equal to 2 cosine of theta minus 2 times cosine of 2 theta. Cosine squared minus sine squared, that little piece right there is equal to the cosine of 2 theta, just that piece right there. And then in the denominator, we have negative 2 sine theta, and then plus 2 times sine of 2 theta. This piece right here, that's the double angle formula for sine of 2 theta. Well, now we're trying to look for vertical tangent lines, not asymptotes, but tangent lines. And we're looking for horizontal tangent lines. To find vertical tangent lines, we're going to set the denominator equal to 0. We have negative 2 sine of theta plus 2 sine of 2 theta equals 0. We're going to use our calculator to solve this. And let's go through the setup. We have the mode. We want function mode, and we want radians. And let's go to the window, and we're going to graph this from 0 to 2 pi. And we can go by pi divided by 12. And the reason we pick pi divided by 12 is because it has the pi over 4s, it has the pi over 3s, and it has the pi over 6s. It has everything that we're looking for. Maybe we go from negative 4 to 4 on the y's, and we'll see if that fits for our functions. Let's graph the vertical tangent, negative 2 sine of theta, and then minus, actually it's plus, oh, let me close the parentheses there, plus 2 sine of 2 theta. And we want to know where this is equal to 0. So here we go. We're going to graph it. Well, it's 0 at 0, and then we have some other places that we're going to have to look at. If we trace this, that's right down the middle. That's actually pi, but that's the 12th pi over 12. So let's start over here at 0. So one of the answers we have is theta equals 0. And then, as we move along to the right, this is 4 pi over 12, which is pi over 3. So pi over 3 is a 0. Then, if you count over, this all the way over here is 12 pi over 12, or pi. There you see the 3.14. So pi is one of the answers. And then we go, that's 12, 13, 14, 15, 16, 17, 18, 19, 20. So once we get over to this other one, this is going to be 20 pi over 12, and we'll just have to reduce that fraction to see where exactly we are. So 20 pi over 12, that's 10 pi over 6, that's 5 pi over 3. So 5 pi over 3. Now let's do the same thing for horizontal tangents. Horizontal tangents is where the derivative is 0. How do you make a fraction 0? You make the top 0. 2 cosine of theta minus 2 cosine of 2 theta. We want that to be equal to 0. So we go to y equals, clear this out, 2 cosine of theta minus 2 cosine of 2 theta. And we'll see where this is 0. Well, it's 0 at 0, and it looks like a couple other places. And of course, it'll hit at 2 pi as well if 0 is one of them. So theta is equal to 0. And then we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 pi over 12. 8 pi over 12. That's 2 pi over 3. And then if we keep going, there's 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm all the way over to, let's see, where are we at? Right there. There's 16 pi over 12, which is 4 pi over 3. And then the other one is 2 pi, but that's the same as 0. Well, we kind of have a problem here. we can't have a vertical tangent line and a horizontal tangent line at 0, so we're going to try to figure out which one it actually is. So we want to find out, is this tangent line approaching vertical, or is this tangent line approaching horizontal as we go around this curve? And to do that, we're going to take the limit as theta approaches 0 of the derivative. So the derivative is 2 cosine of theta minus 2 cosine of 2 theta over negative 2 sine of theta plus 2 sine of 2 theta. But we already know from solving these that we have 0 over 0, but that's an indeterminate form, so we're going to use L'Hopital's rule. Limit as theta approaches 0 of the derivative of the top is negative 2 sine theta, and then that's going to be plus 4 sine of 2 theta. All over the derivative of the bottom is negative 2 cosine theta plus 4 cosine of 2 theta. And now we got to plug 0 into these. The sine of 0 is 0, so we get 0 plus 0 on top. But in the denominator, the cosine of 0 is 1, so we get negative 2 plus 4. We get 0 over 2, that is 0. So we have a horizontal tangent line at 0, not a vertical. So this does not count in the vertical part. We need to find points of tangency. That's what the instructions say. Find the points of horizontal and vertical tangencies. We know the theta, but now we need to know the r. And r is 2 minus 2 cosine. r is equal to 2 minus 2 cosine of theta. So we need the points r, theta. We know the thetas. So let's look at horizontal. Horizontal is over here, and that's something comma 0, something comma 2 pi over 3, and something comma 4 pi over 3. So we have to plug these values into the function. We have for this one 2 minus 2 cosine of 0. Cosine of 0 is 1, so this is the point 0, 0. Then we have 2 minus 2 cosine of 2 pi over 3. And the cosine of 2 pi over 3 is negative 1/2. We have 2 minus 2 times negative 1/2. That's 2 minus, that's actually 2 plus 1. That's 3. And then we have 2 minus 2 cosine of 4 pi over 3. And the cosine of 4 pi over 3 is, we have 2 minus 2 times negative 1/2. That's again 2 plus 1. That's 3 also. So there's 3 points that we're looking for. That's the horizontal. And I'm kind of running out of room here, but we'll make do. And then over here, we have, for the vertical, is something comma pi over 3, something comma pi, and then something comma 5 pi over 3. And we got to plug those values into the function. So we have 2 minus 2 cosine of pi over 3. So 2 minus 2 cosine of pi over 3 is 1/2. 2 minus 1 is 1. And then when we plug pi into cosine, we have negative 1. That's 4. And then finally, we have 2 minus 2 cosine of 5 pi over 3. Well, the cosine of 5 pi over 3 is 1/2, so we have 2 minus 1 again, and that is 1.